So in this video, let us try to see how to do the torsional pendulum experiment. So the aim of the experiment is to determine the couple per unit twist of the given wire and to calculate its rigidity modulus. A torsion pendulum is an arrangement where a wire is rigidly fixed at the upper end and to its lower end a disc is attached, and by holding it at the check nut, if given a slight twist like this, the disc executes torsional oscillation. These oscillations are simple harmonic in nature. Suppose if we put a mark like this using a chalk piece, so that mark will execute SHM. So from the theory, it is known that the time period of torsional oscillation is given by 2 pi into square root of I by C, where C is the couple per unit twist and I is the moment of inertia of the disc about wire as the axis. So from this formula, you can calculate the couple per unit twist by experimentally calculating the value of moment of inertia and time period of the torsional oscillation. Also, the rigidity modulus of the material of the given wire is given by 8 pi L divided by R power 4 into I by T square, where I is moment of inertia, T is time period of torsional oscillation, L is length of the pendulum, which is measured from upper check nut to lower check nut, end of the lower check nut, and R is the radius of the wire. Coming to the experimental part, to start with, the mass of the disc is measured using the rough balance, and then the radius of the disc is calculated by measuring its circumference using a thread and the scale like this, and then the length of the wire is measured using the thread. Yes. Using the thread, the length of the wire is measured and then the radius of the wire is measured using the screw gauge by fixing the screw gauge at 3 different positions. And the measurement of radius of the wire is very important because in the formula we have R power 4 in the denominator. Even a slight error in the measurement of radius can lead to a lot of error. Coming to the measurement of time period of torsional oscillation, the disc is given a slight twist by holding it at the check nut like this. So now, as the pendulum oscillates, a line drawn on the disc is also oscillating. By using this as the reference, I am going to start the clock from the right extreme. And if the line goes to the left extreme and comes back to the right extreme, that constitutes one complete oscillation. So like this, I'll allow this pendulum to complete 20 oscillations and record the time for 20 oscillations. Now I'll demonstrate the experiment. So now the pendulum is in oscillation state. So now when the line reaches the right extreme, I'll start the stopwatch and start counting the oscillations. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'll stop the stopwatch. Now you can see that time for 20 oscillations is 29.9 seconds. So this digit is also very important. Therefore, let us take it as 29.9 seconds. And the experiment is repeated for 3 trials. The experiment is repeated with wire passing through the diameter. So this acts as the axis. About this axis, again the pendulum is set into oscillations like this, and time for 20 oscillations are recorded. Tabulation, coming to the tabulation part of the part. So this column represents the axis of rotation. So in the first case, what we have done, axis passing through the center and perpendicular to its plane, and in the second case, the axis passing through the diameter, and this is the disc what we are using. And then moment of inertia, in the first case the moment of inertia is I is equal to mr square by 2, and in the second case I is equal to mr square by 4. By knowing the value of m and r, this moment of inertia can be calculated. And then here this the rows are actually for time for 20 oscillations in first case, and these 3 for time for 20 oscillations in the second case. And mean time for 20 oscillations in both the cases is calculated, and using these you can calculate the time period of oscillation. By knowing the values of I in both the cases and t, you can calculate I by t square, and if we have done the experiment correctly without any errors, then the values of I by t square in both cases are almost the same. So now the mean value of I by t square is taken, and this mean value of I by t square is substituted in this formula to calculate the couple per unit twist, and then in this formula to calculate the rigidity modulus of the material of the given wire. So therefore, to conclude with, so using this torsional pendulum, we have calculated the couple per unit twist of this given wire and the rigidity modulus of the material of the given wire.